good morning everyone. I am Arpita Agarwal and I am assistant professor in AKGC, and today I am taking DSTL Boolean Algebra BCS code 303. So today we are studying some laws of Boolean Algebra and their proofs. First law we are studying is idempotent law. So what an idempotent law is, if we add an element to element, then it is A. If we multiply an element to element, then again it is A. And we will be proving these two laws also. So we are taking the first law. We are taking LHS. And if we multiply it by 1, there will be no effect for it. So now we open the bracket. So we have multiplied it by 1 and we will be getting this as A plus A. We can write 1 as A plus A complement by identity law. In place of this one, we have write it as A plus A complement, which is by identity law. Now we will take A common from both the brackets. Then we will get in bracket A dot A complement. That is A dot A complement will be 0 by the again identity law. And this is 0. So here it is, we are having a plus, so A plus 0 will be A. So we have taken LHS, that is A plus A, and we are getting RHS, that is A. Now we were having law this A plus A equal to A. So we have proved, we have taken LHS and we have proved RHS. Now we are taking RHS. We are adding 0 to this A. In place of 0, we can write it as A dot A complement by identity law again. So by distributive law, we can write it as A plus A dot A plus A ka complement. So what is A plus A? Again A, and A plus A complement, what we can write it as 1. So we have took the A and we have got A again. So this is our idempotent law. So now we second idempotent law was A dot A equal to A. So we take again LHS. We will add 0 to it. By identity law, it is A dot A complement. Take A common. We have done this by following distributive law. So this is A. We have got the required answer. So we have proved the idempotent law. Now we are taking another theorem of Boolean algebra for every element of Boolean algebra be A plus 1 equal to 1 and A dot 0 equal to 0. So now we are taking the first proof, that is we are taking the LHS of it. And what is the LHS of it? A plus 1. So in place of 1, we can write it as A plus A complement, and it is by complement law. We have studied earlier complement law. So it is by complement law. So take A common, and this is this A complement. So A. So we will get A plus A complement. From this we get A, and from this we get A complement, and it is 1. So we have taken A plus 1 and we have got 1 as RHS. Now we will take as A dot 0 equal to 0. By complement law. So by complement law, we have to prove this. So A dot 0, in place of 0, we can write it as A dot A complement. So take A one side and remaining is A complement. We have done this by associative law. So A is A, and A dot complement, and A dot A complement by complement law is 0. So we have taken the LHS, that is A dot 0, and we have proved RHS, that is 0. So now again we were having two things. First we have proof, second we are doing this A dot 0 equal to 0. We have to prove this. So we are taking LHS of it again. So A dot A complement, A dot A complement by complement law. By idempotent law. And what is A dot A complement is 0 by complement law. So next we are having a absorption law. So in absorption law, we have to prove A plus A dot B equal to A, and second we have to prove A dot A plus B equal to A. So we will take LHS of first, that is A plus A dot B, that is A dot 1 plus A dot B. We are applying it identity law to it. So taking A as common from both, we get 1 plus B. So this is by distributive law. So 1 plus B is 1 by again an identity law, and A dot 1 is again A. So we have taken LHS and we have proved the RHS, that is A. Now we are taking the second term, that is A plus B equal to A. Now again we will take LHS. So this is by distributive law. So A 0 dot B will be 0, because anything we multiply with 0 will be 0. So A plus 0 will be A, and it is RHS. So we have taken this and we have proved it as A. So LHS is equal to RHS. Now we have taken another law, that is associative law. Now we are taking, these are the two associative laws. We are taking the proof of it one by one. So proof of first, that is, we are taking LHS of it, A plus B plus C. So multiply 1 to it, A dot 1 plus B dot C dot 1. So what is A dot 1? 1 plus B dot 1 plus C dot 1. And how it is this? By distributive law. So this is A plus B dot 1 dot C dot 1. So again A plus B plus C, and we have to prove this in RHS. So our LHS is again equal to RHS. We are taking the second law of associative law, that is A dot B dot C equal to A dot B dot C. Take LHS of it, that is A dot B dot C. I want you to try it for yourself. Same we have done this, you try for this. Third we are studying is complement law of a Boolean algebra. So complement law is 0 का complement 1 and second is 1 का complement equal to 0. So we are taking first LHS, that is 0 complement. So what are 0 complement is 0 plus 0. And how it is this? Because identity law says that A plus 0 equal to 0. So what is anything plus with this complement is 1. It is by complement law. Now we are taking the second complement law, that is 1 complement equal to 0. So 1 complement is equal to 1 complement dot 1, because A dot 1 is equal to A by identity law. So 1 dot 1 का complement will be 0 by complement law. So we can say that LHS is equal to RHS. So it is an important theorem. We are taking it as right now in Boolean algebra. The complement of each element of Boolean algebra is unique. So proof of it, A plus X, we have to prove two things in it. We are given with two things and we have to prove X is equal to Y. So if we have an A and B, two elements such that A belongs to B and X and Y are complements in a set. So A plus X is equal to X plus A equal to 1, and we have two conditions for it. A plus X or X plus A, one and the same thing. is 1 and second is a dot x equal to x dot a equal to 0. So a dot y plus a equal to 1 and a dot y equal to y dot a equal to 0. So suppose we have say it as a one equation. Because we know this by identity law. So now we will take as first LHS. We have to prove x is equal to y. So we will take LHS, we will take x. So if we multiply x dot 1 by identity law, we are given with that x plus a is equal to 1. So if we write it a plus x from the given condition, a plus y and a plus x, we can write it as y also from the given condition. So open the brackets. X dot a is equal to 0 by given condition and remaining is x dot y by distributive law, and we will get y dot 1, that is y. So we have taken LHS and we have proved it as RHS. So try it yourself by taking plus. Okay, so that's all for today, and we will be taking next theorems in next lecture. So thank you.